Hello, class. I'm thrilled that you're all here. Today, we're taking an exciting deep dive into the world of stoichiometry, a cornerstone of chemistry that's not just fascinating, but also incredibly practical. So, first of all, what is stoichiometry? At its core, stoichiometry is all about quantities in a chemical reaction. The term comes from the Greek words stoichion, meaning element, and metron, meaning measure. In chemistry, stoichiometry helps us quantify the amount of reactants consumed and the amount of products generated during a reaction. Key concepts in stoichiometry. The mole. The mole is a fundamental unit in chemistry. It's like a chemist's dozen. 1 mole of any substance contains exactly 6.022 by 10,236.022 times 10 carat 23 6.022 times 10. 23. Particles, atoms, molecules, etc., which is known as Avogadro's number. This large number allows us to easily relate microscopic amounts of substances to macroscopic amounts we can measure. Mole ratios. Mole ratios are derived from the coefficients in a balanced chemical equation. They tell us how many moles of one substance are needed or produced for every mole of another. Think of mole ratios as the secret recipe to your favorite dish. For example, in the reaction, 2H2 plus O2 to H2O, the mole ratio of H2 to O2 is 2 to 1, which means 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water, limiting and excess reactants. Now let's add a fun twist. In any reaction, one reactant tends to limit the amount of product formed. This is the limiting reactant. The limiting reactant, also known as the limiting reagent, is the substance that is completely consumed first in a chemical reaction. Once this reactant is depleted, the reaction cannot continue, and no more products can be formed. Example: in the reaction between hydrogen, H2, and oxygen, O2 to form water, H2O, if you have a limited amount of oxygen, that will determine how much water can be produced even if you have excess hydrogen. To make it more easier and clear, take a daily routine example. Imagine baking cookies with only 1 egg. If your recipe needs 2 eggs, the egg is the limiting reactant because it restricts the number of cookies you can bake. The excess reactant, also known as the non-limiting reactant, is the substance that remains after the reaction has completed. This reactant is not fully consumed and does not limit the amount of product produced. Example: continuing from the previous example, if you have more hydrogen than necessary to react with the available oxygen, hydrogen is the excess reactant. Some hydrogen will be left over once the oxygen is used up. Example: continuing from the previous example, if you have more hydrogen than necessary to react with the available oxygen, hydrogen is the excess reactant. Some hydrogen will be left over once the oxygen is used up. Let's relate it with daily life. Use TO, make it also easier. This is like having more flour than you need. You can keep baking until your other ingredients run out. Percentage composition. Percentage composition is a way to quantify the relative amounts of each element in a compound. It helps you understand what percentage of a compound's mass comes from each element. To calculate it, you can use the formula percentage composition SAD face molar mass of element in 1 mole of compu ND/molar mass of compound times 100%. This is useful when you want to know the contribution of each component in a compound. Yields. In chemistry, the term yield refers to the amount of product obtained in a reaction. Theoretical yield. This is the maximum amount of product that could be formed from the given amounts of reactants, based on stoichiometric calculations. Actual yield. This is the amount of product you actually obtain from a reaction, which can be less than the theoretical yield due to various reasons, like side reactions or incomplete reactions. Percentage yield is a measure of the efficiency of a chemical reaction, expressed as a percentage. It represents the ratio of the actual yield, the amount of product obtained from a reaction, to the theoretical yield. Given reaction 2H2 plus O2 to H2O. Question: if you start with 10 grams of H2 and 20 grams of O2, how many grams of water can you produce? Step 1. Convert grams to moles. Molar mass of H2 equals 2.02 grams per mole. Moles of H2 equals 10 g/2.02 g/mole is almost equal to 4.95 moles. Molar mass of O2 equals 32.00 grams per mole. Moles of O2 equals 20 g/32 g/mole is almost equal to 0.625 moles. Step 2. Determine the limiting reactant using mole ratios. The balanced equation shows a 2-to-1 ratio of H2 to O2. For 0.95 moles of H2/2 equals 2.48 moles of O2 needed. Since you only have 0.625 moles of O2, which is less than 2.48 moles, O2 is the limiting reactant. Step 3. Calculate moles of water produced. From the mole ratio, 0.625 moles O2 times 2 moles of H2O/1 mole of O2 equals 1.25 moles of H2O. Step 4. Convert moles of water. 2 grams. Molar mass of H2O equals 18.02 grams per mole. Mass of H2O equals 1.25 moles times 18.02 g/mole is almost equal to 22.53 g. Now we have theoretical yield of 22.53 grams of water. Step 5. Determine percent yield if you have actual yield. Suppose after conducting the experiment you measure that you actually obtained 20 grams of water. Then, percent yield sad face 20 g/22.53 g times 100 is almost equal to 88.8%. We've tackled the essentials of stoichiometry together today, and with practice, you'll find it's a powerful tool in your chemistry toolkit. If you enjoyed this lesson, please give us a thumbs up and share it with your fellow science lovers. And let me know in the comments if you have any questions.